Welcome to our first look at the upcoming winter season, a time of year that always brings its own set of surprises and challenges. As we turn the calendar to the winter of 2025-2026, meteorologists and weather enthusiasts alike are watching the skies and the oceans for clues about what's to come. This year, a major player is already making moves: La Niña, a powerful and sometimes unpredictable climate pattern that has the ability to shake up weather across the globe. La Niña forms when the surface waters of the equatorial Pacific Ocean become cooler than average. This cooling sets off a chain reaction, triggering atmospheric changes that ripple outward, influencing weather far beyond the Pacific itself. It's essentially the opposite of El Niño, which brings warmer waters and different weather impacts. Right now, a weak but significant La Niña is taking shape, and its effects are already being felt in some regions. This developing La Niña is expected to be a key driver of our weather patterns, not just for a few weeks, but throughout the entire fall and winter seasons. The ocean and atmosphere are in constant conversation. When the vast Pacific cools, it sends signals that can change everything from storm tracks to snowfall amounts, and even the intensity of cold snaps. North America, in particular, often feels La Niña's impact most directly. The pattern tends to steer powerful weather systems toward the United States and Canada, influencing where storms form, how much snow falls, and even the severity of winter cold. Europe's weather, on the other hand, is shaped by a more complex set of factors. While La Niña is just one piece of a much larger puzzle, its influence can still be felt, especially when combined with other atmospheric patterns. Current forecasts suggest that this La Niña will continue to strengthen as we move deeper into winter, maintaining its grip on global weather before gradually fading away in the spring. Meteorologists are hard at work, running advanced computer models and analyzing vast amounts of data to predict where snow will fall, where it might be scarce, and how temperatures could swing in the months ahead. In the next chapter, we'll dive deeper into what these models are saying about the upcoming La Niña winter for the US, Canada, and Europe, so you can be prepared for whatever this season has in store. How does a vast pool of cool Pacific water end up changing winter for millions of people across North America? The answer lies thousands of miles away, deep in the Pacific Ocean, where subtle shifts in temperature can ripple across continents and shape the season in dramatic ways. It's all about the jet stream, a powerful river of air high above us that acts like a conveyor belt for weather systems, steering storms and cold fronts across the continent. During La Niña, high pressure builds over the North Pacific, nudging the polar jet stream northward before it plunges south over North America. This altered path allows frigid Arctic air to spill down into the heart of the continent, setting the stage for dramatic temperature drops and winter storms. This shift means colder, stormier weather for the northern US and much of western and central Canada. Cities from Seattle to Minneapolis and regions across the Canadian prairies often brace for more frequent snowfalls, icy winds, and blizzard conditions. Meanwhile, the southern US usually enjoys a break from harsh winter, staying warmer and drier as the jet stream's path keeps cold air at bay. Places like Texas and Florida often see mild, sunny days while the north shivers. History shows this pattern is reliable, especially in weak to moderate La Niña years. Meteorologists track these trends using decades of weather records, and time after time, La Niña delivers its signature winter setup. Cold air colliding with moisture-laden systems means big snow for the northern plains, the Great Lakes, and western Canada. These areas can see above-average snowfall, with storms piling up drifts and creating classic winter scenes. Snow cover in Canada acts like a giant refrigerator, keeping air masses cold as they move south. This helps boost snow chances in the Midwest and Northeast, as chilly air sweeps over the landscape and meets new storms. An early, snowy start in Canada often signals more snow farther south later in the season. When snow piles up early, it sets the tone for a long, wintry stretch ahead. In the end, La Niña sets the stage for classic winter weather in these regions: snowy streets, bundled-up kids, and the kind of winter scenes that define the season for millions across North America. With cold air in place, the odds of a snowy winter rise in parts of North America. The storm track during La Niña favors the Pacific Northwest, Northern Rockies, and Great Lakes, prime spots for above-average snowfall. The Northeast and Eastern Canada can also see big storms, especially if nor'easters develop off the coast. The exact storm track matters. A small shift can mean snow or rain for major cities. The southern U.S. usually gets less precipitation, which can be a concern for water supplies. La Niña creates a winter of haves and have-nots for snow and rain. For 2025-2026, expect enhanced snowfall in Canada, the northwestern U.S., northern plains, and Great Lakes. The Northeast has a good shot at an active winter, but models sometimes surprise us. These forecasts balance La Niña's influence with other climate factors. Let's see what the models are showing. Now, let's look at Europe, where forecasting is trickier. Europe's weather is shaped by the Atlantic, Arctic, and jet stream, with La Niña as a subtle influence. We rely on long-range forecasts from the ECMWF and UKMO, two top weather centers. Comparing these models shows where there's confidence and where uncertainty remains. Sometimes La Niña can bring colder conditions to northern Europe by encouraging high pressure near Greenland or Scandinavia. This can block mild Atlantic air and let Arctic cold spill south, but it's not guaranteed. Let's see what the ECMWF model predicts for European snowfall. The ECMWF model forecasts less snowfall than average for most of Europe early in winter. Scandinavia is the main exception, with above normal snow likely in the far north. November looks mild, with snow limited to high elevations. December continues the trend, but hints at more snow in the central Balkans and southern UK. By January, there's a slight uptick in snow potential for Central Europe and the UK, possibly signaling a pattern shift. Overall, the ECMWF suggests a slow, mild start to winter, but with a few areas primed for snowy surprises. Watch for changes in January if a northern high-pressure block develops. Localized snow events could still pop up despite the mild outlook. The UKMO model predicts an even milder, less snowy winter for Europe than the ECMWF. Most of the continent sees below-average snow, except for far northern Scandinavia. November through January, snow is mostly confined to high northern elevations. The UKMO is known for forecasting mild, low snow conditions. Both models agree. A slow, gentle start to winter for Europe, with only a few glimmers of hope for snow lovers. The main difference is that the ECMWF hints at a possible pattern change in January. Uncertainty remains, so we'll keep watching for updates. Back to North America, the ECMWF model predicts below-average snowfall for much of the U.S. early in winter. This is unusual for La Niña, especially in the Midwest and Northeast. The model does show more snow for the Rockies, Great Lakes, and parts of Canada. November highlights above-normal snow in the central Rockies and a belt from Iowa to Illinois. December brings more snow to southern Canada and the upper Midwest, with a surprise area in the southeast. By January, the pattern looks more like a classic La Niña, with snowier conditions in the west and north-central U.S. The Northeast stays drier and less snowy, which is a surprise. This shows how complex and changeable long-range forecasts can be. The UKMO model offers a different take for North America. It predicts more snow for the northwestern U.S. and western Canada. Classic La Niña territory. The southern and eastern U.S. plus southeastern Canada are expected to be drier and less snowy. November is mild and dry for most, but December brings a snowy shift to Canada and the northwest. January sees a major snow increase in Canada and the northwestern U.S., with the upper Midwest also getting in on the action. Both models agree on less snow for the Northeast, which is unusual for La Niña. This shared signal suggests another climate factor may be at play. The differences highlight the uncertainty in long-range forecasts. Why do models disagree, or sometimes deliver unexpected results? The answer lies in the complexity of long-range forecasting, which is one of the most challenging tasks in meteorology. When we try to predict the weather months in advance, we're essentially attempting to forecast the behavior of a chaotic system. The atmosphere is influenced by countless variables, and while La Niña is a major player, it's only one part of a much larger and more intricate puzzle. There are many other factors at work, like the Arctic Oscillation, which can dramatically alter weather patterns across the northern hemisphere. Sudden stratospheric warming events, for example, can disrupt the polar vortex and send cold air plunging south, completely changing the outlook for winter in just a matter of days. To tackle this complexity, meteorologists rely on sophisticated computer models like ECMWF and UKMO. These models process billions of data points from around the globe, but each one has its own unique strengths, weaknesses, and built-in biases. Early in the season, forecasts often tend to lean warmer or drier than what might actually occur. That's why experts compare multiple models, looking for areas of agreement and disagreement to build a clearer, more reliable picture. Timing is crucial. Right now, it's early October, and La Niña is still in the process of developing. The full impact of this climate pattern won't be felt until later in the season. As we move closer to winter, the models become more accurate. That's because atmospheric patterns start to settle in, and the signals from major climate drivers become clearer. Think of these long-range forecasts as a blurry photograph that gradually comes into focus. The closer we get to winter, the sharper and more detailed the picture becomes. For now, the best guidance suggests a colder, snowier winter is likely for western and northern parts of North America, with the potential for significant snowfall in some regions. Meanwhile, Europe is expected to experience a milder winter overall, with less snow than usual, especially in central and southern areas. But remember, the details, especially for places like the Northeast US, are still uncertain. Small shifts in atmospheric patterns can make a big difference in local weather. So, treat these forecasts as helpful guides rather than absolute guarantees. They offer valuable insight, but there's always room for surprises. We'll continue to monitor the data and update our outlooks as the season approaches and new information becomes available. Thanks for joining us for this first look at the global winter ahead. Stay tuned for more updates as we track the evolving forecast together.